process that the compounder carries out is called companding. So as you can see, companding will stand for compression. We will compress the large amplitude changes, and expansion, well, we will expand the small varying signals. So the question is how this compounding process is obtained. So we have the standard circuits which will carry out this process. If you have observed carefully, the process of compounding will change the nature of the signal. It will change the original signal because you are compressing signal in some part, you are expanding signal in some part. On the receiver side, when you try to recover the signal from digital form to the analog form, it has to go through the inverse process, the process which is inverse of compounding. That means on the receiver side, we'll have to compress this expanded signal, and the signal where it was compressed, we should expand it. So we should carry out the inverse process, and hence the process of compounding must be standardized on the transmitter side. You cannot do the compounding in any random way because the receiver must carry out the inverse process of compounding. Hence, receiver can design an inverse system only if it has a perfect knowledge of the actual compounding system that was used on the transmitter side. And hence, the compounding process is standardized with the help of two different types of compounding systems being used. In some countries, the compounding is done using a system called mu law. Mu law is nothing but a name given to the compounder, and in some countries, the compounding process is done using A law. Let us see what are the definitions of mu law and A law and how do they look like. Mu and A will stand for the parameters that we use in this particular processes. So let's see how mu law is defined first. The output level mod V is defined as log of 1 plus mu times mod M divided by log of 1 plus mu, where mu is nothing but a parameter which will control the amount of compounding. Mod M is nothing but the normalized input signal, and mod V is nothing but the normalized output signal. If we look at the input output characteristics of mu law compounding system, then we get a better idea towards how this compounding process is carried out. Similarly, the second compounder is called A law. In case of A law, the normalized output is defined with respect to two different definitions. In the first part, the definition says the output level should be A mod M upon 1 plus log A. This is valid when the input normalized signal is between 0 and 1A. That means when it is taking small values. And the output level will be 1 plus log of A mod M divided by 1 plus log A. This will be the case when the input normalized values are between 1 by A and 1. So that's the difference between the two definitions. Here A is the parameter which will control the amount of compounding. When mu is equal to 0 and A is equal to 1, it corresponds to no compounding. And the typical values of mu and A which are used in most of the systems are mu equal to 255 and A equal to 87.6. These are the standard typical values which are used in most of the practical systems. So once we have well-defined input-output relationship for the compounding process, we can always design the inverse system and we can obtain the original signal which was there before the compounding on the receiver side.